Another text problem gives us the function f of x equals 4x cubed plus 6x squared minus 23x plus 7, and asks us to find where the derivative f prime of x is greater than 1. Now how do we start this problem? Well, since we're asked a question about f prime of x, I guess it's probably a good idea to go ahead and take the derivative to find the f prime. So f prime for this function, and I'm not going to go through the details, is 12x squared plus 12x minus 23. And we want to solve for where that is greater than 1. Now, this looks like a quadratic. It is a quadratic. What do we want to do with a quadratic? Instinctively, if we have any experience with the quadratic formula and so forth, we want a quadratic to be related to 0, to be equal to 0, or in this case greater than 0. So we subtract 1 from both sides, we get 12x squared plus 12x minus 24 is greater than 0. Now how are we going to determine where this is greater than 0? Well, if we had a graph of this expression, 12x squared plus 12x minus 24, we might well be able to determine where the zeros are. So the question is, where are the zeros? I'm paying homage here with the where to my old milkman Cecil when I was a kid. Cecil used a lot of whars and thars and thars. So where are the two zeros here? Okay, well, we can find them fairly easily just by using the quadratic formula. We set this expression equal to 0, we'll find where the graph crosses the x-axis. And that's pretty standard, very straightforward. We'll say that where is wherever 12x squared plus 12x minus 24 is equal to 0. We'll go ahead and divide through by 12 to make this simpler, because when you go into the quadratic formula, if that's what you do, you don't want big numbers to square and multiply by each other and so forth. This makes the numbers a lot simpler. In fact, if we look at this, we can see that this is real easy to factor, and we won't even bother with the quadratic formula, although if you didn't see how to factor, you could use the quadratic formula. We'll factor this into x plus 2 times x minus 1, which gives us, when set equal to 0, gives us x equals negative 2 or x equals 1. So, we've answered the question where. At negative 2 and at 1, this expression, which represents the derivative f prime of x minus 1, is going to be equal to 0. Okay? Now remember that this expression does represent what we got when we subtracted 1 from both sides of this equation, and this side was your f prime of x. And that's why I say that this is f prime of x minus 1. We've got a graph here of f prime of x minus 1. Well, it's real clear that on this side of negative 2, that f prime of x minus 1 is going to be greater than 0, which of course means that f prime of x is greater than 1. Between negative 2 and 1, of course, f prime of x minus 1 is negative, so f prime of x is less than 1. Then over on this side, again, we get f prime of x greater than 1. Okay, and this here indicates that this is the graph of f prime of x minus 1. So this solves our equation. For x less than 2 or greater than 1, we have f prime of x greater than 1.